my other tutors. Like if I mention things like bar charts, pie charts, and histogram, definitely the person that will teach you Power BI or Excel or Tableau will obviously mention these things too in this too. So another thing is that I won't obviously talk about the whole of the statistics that is inside data. The time frame is actually short, but I will try as much as possible to give you the necessary details that you need to understand so that in the long run you can go and read on your own and just get to have a proper understanding. So let me try to share my just give me a second. Let me try to share my screen, and I'm assuming that literally everybody have the uh the slides with them. I'm going to assume that. So let's just get a kick started. So thanks to my Oga Mr. Adewale Yusuf, my namesake, uh for for giving me this opportunity. I'm really happy to be here. So let me just share my screen this up. All right, I think I'm here already. All right. Okay, we have a lot of messages coming up. Okay. I know of my sorry, I used to mix a pidgin with my English, so I beg one and no vex give me. All right. So let's go. All right, I think you should be able to see my screen soon. Just give me a second. It should be okay, yeah. So I don't know if you can see my screen. Just say hi to me and let me know if you can see my screen.
I can
All
see
right.
your screen, sir.
All right. Thank you very much. So, by the way, moderator, is everybody has the slide, right? Or they will have it after the class?
We don't usually provide this slide, so it's what you
Oh, okay, okay.
present.
Okay, that's fantastic. It's fair because there are some classes they will tell they should provide a slide and you give it to them later on, but that's fine. All right. So basically, statistics for data analysis. Now, this is a very, in as much as I don't like saying this thing, it seems like a controversial topic because people still feel like there are people that still think you don't need statistics to become a data analyst. Well, I used to tell them, well, to a degree, you are right, but when things get tough, that is where you need statistics. And my second point is define data analysis, define statistics. You will notice a very clear similarity between them because statistics is a branch of mathematics that deals with how you collect, organize, analyze, and present data in order to draw out conclusion from that data to solve problem. Is that not the definition of data analysis? It is obviously. So anybody that tells you you don't need statistics for data analysis, the person wants to mislead you because in the long run you will still have to go back to the basics. And like I used to say, the foundation of tech in general is deeply rooted in mathematics. So one way or the other, you will still meet mathematics in this tech space. It might be very little like algebra, and it might be advanced like calculus, but you still meet it because math is the framework of tech. So the ground rules we need to talk about. Okay, I think this is not really there. You can ask questions probably after the class, and make sure that your mic is mute. And if you have something to say, you can just put up your hands. Okay. So this is me. People know me on Twitter. I don't think I'm a celeb on Twitter, but then I just did my day. So this is my profile, and like I said earlier on, I have a YouTube channel where I teach statistics for data analysis and machine learning. You can actually hop onto my channel. I have well-made videos that you actually enjoy, and you can also follow me on Twitter too. I'm very vibe. I'm I'm a vibe. Like let's just put it that way. So let's start by defining the key term. So what is statistics? I have actually just defined this. So in simple terms, statistics is a branch of mathematics that deals with how we collect, organize, analyze, and visualize data, and also presents these data sets in order to draw out conclusion from the data to solve an actual problem. So the key terms right here is data and how you collect, organize, and analyze this data set. In fact, this is the bedrock of data analytics because there is a way we collect data for analysis, there is a way we organize and prepare data, there is a way we analyze data, and there is a way we visualize data. In fact, the order of analyzing data is more or less like you collect it first, then you prepare it and clean it, which is more of the organizing. Then after doing that, you analyze it and then you visualize it. So those are the first steps that defines data analytics. And like I said, other tutors will touch each of those things, but see this class as a theoretical aspect of all things. So statistics can be applied to literally all fields. Okay, the same way we can apply data analytics to all field. Now, that being said, let's talk about the types of statistics. Now, basically, we have two types of statistics, and this is where I think people mix it up when they say you don't need statistics for data analysis. Now, see it here. We have two types of statistics. We have descriptive statistics and we have inferential statistics. So, as the name implies, descriptive statistics, it comes from the word describe, to summarize. Oh, Abefe is a fine boy. Yeah, you're describing me. Oh, Abefe talks a lot. You are describing me. Abefe is a tall guy. You are describing me. Mr. Adewale is a fine man. You are describing him. You are summarizing him. So, firstly, it comes from the word descriptive, which is synonymous to you describing, or we can say summarize. So, in simple terms, descriptive statistics is a branch of statistics that is used to summarize or describe your data set. Now, whatever you want to do in the data space, if you have been watching your bosses, our guys on the top, most times everything they want to do, they pass analyzing the data sets, use mean media mode, get the KPI, do this, do that, and visualize data. So most times, as a data analyst, the statistics that you will need, most times it will end at descriptive statistics. Meaning you might not there might not be a need for you to use inferential statistics. So let me try to talk more on descriptive statistics first. So basically, after you can summarize your data with this, it has two aspects. So under the descriptive statistics, we have the visual summarization. Now, this place we use charts to summarize our data sets. Now, this is what we call data visualization. Now, a picture they say what 1,000 words, and trust me, statistics is not left behind. In as much as there is a lot of mathematics in statistics, it makes sense sometimes to actually tell a story about your data set using pictures. Yes, numbers can tell a lot of stories, a lot of information, but sometimes using charts, tables, and all of those beautiful things can actually just make things are pleasing to you. We humans are attracted to charts. We humans we understand visual information easily. Yes, it makes sense. If I throw some numbers at you, like let me say like age of people in this group or on this call right now, I throw it at you and I make that age or that number or this data and I maybe make it into a bar chart, you will appreciate the bar charts more than the raw number. In fact, from the bar chart, you can be like, oh, so we have this high number of age group. There are older people on this group. There are younger people here. So we tend to understand visuals very well. So that's why in statistics, we try to summarize our data sets using visual information. And there are a lot of them. We have the likes of the bar charts, the pie charts, the histogram. Now you must have heard of all of those things before. It's not new to you. Even I don't know if they still do this thing right now. I'm not old, but when I was in secondary school, we were taught statistics in SS2. I don't know if we have any non-Nigerian here, but SS2, I mean probably my fifth year in high school or in secondary school. So we were taught the basis of statistics. So I feel one way or the other, you must have actually come across this thing. Now, at some point in time, you will need to know when to use your bar chart, when to use your pie chart, when to use your histogram. These are things that I will touch briefly, and the person that will teach you the data visualization properly will also teach you how to use softwares. Now the beauty of statistics is that I used to tell people that imagine somebody that knows how to do 10 times 50 times 100 in their head, in their mind. This person can do calculations in their head, but calculator was now invented, so this person just needs to know what to press and how to use a calculator. So someone of this nature is going to appreciate the calculator more because it has reduced the workload, and that is what statistics does to you. If you understand statistics very well, you will understand data, you will understand the framework of data. So Excel, Power BI, Tableau, Python, R, they are just tools. They are just there to assist you. Like I used to say, having plenty knives does not make you a chef. Okay, buying the best pot, the finest gas cooker does not make you a chef. It is how you can mix all of your ingredients together, reduce the temperature with respect to your tools that makes you a good chef or a good cook. So it's not by the tools that you have, it's a matter of how you can use it. So most times when you are poised with problem in data, most times we usually have a solution in our head. So we just use the likes of Excel and Python or Tableau to bring out that solution. So more of that later on, Sha. Don't let me talk too much on that. Now, and the next aspect of descriptive statistics is numerical summarization. Yeah, visuals are good, but we can never forget that statistics is a branch of mathematics, meaning you must crunch numbers. There is no way we can run from that. And under this section, we'll be using numbers to summarize and describe our data sets. Now, each of these numbers have their own interpretation, mathematical formula, and use case scenario, meaning everyone is unique in their own way. I like to say something. The mean median mode that we are shouting about right now, each of them have their use case scenario. And in fact, I would like to use a very common example that they use in the news to report statistics. Okay, so let's start with these our numerical summarization. So we have two types of them. We have the measure of central tendency, aka the measure of location. I think we've heard of this, and we have the measure of dispersion. So under the measure of central tendency, okay, give me a second. Now, under the measure of central tendency, this numerical detail is used to summarize the center of the data set. Now, human beings are attached to middle point, 50%, halfway mark. We are always attached to anything that makes things balance. So mean median mode is the measure of location. Okay, it helps us to locate the center of our data set. It means that when something is at the center, it means it's divided into two equal halves, left half, right half. Now note, there are other ways you can divide your data set, maybe into 4 parts, into 10 parts, into 5 parts, but the center into 2 parts, 2 equal parts, is very important to us. Now, you've all heard of those like these three things before: mean, median mode, MMM. And from the mathematical standpoint, they have their formulas. Okay, so if I give you a small sample data set now, get the mean, get the median, get the mode. You can do that with calculator, with your hand, with formula. But that is where software comes inside. So instead of stressing yourself to be uh calculating this by hand, there are softwares to help you. But your job as a data analyst is to now understand the interpretation of the mean median mode. That is it. It's to understand, when do I use average, when do I use mean, when do I use median if I'm reporting to my oga, when do I use mode, or when can I combine mean, median, mode together to tell a story. Yeah. So in fact, this is heavily used in research, because I can remember it was like a few weeks ago. Well, yeah, a few weeks ago, Paid HR released a research on employment stuffs in Nigeria, and that was a very beautiful research. It's a report that merges statistics and data. It shows the beauty of statistics and data. Look at how they visualize that data. But if you look deep down, it is pure statistics. Now, it's like, that is the beauty of statistics. It makes you understand things to the depths. And now, people in data analysis may not even appreciate the statistics more. It is people in machine learning that will understand it better. Exactly. And people in research. But let's stick to it. Now, under the measure of central tendency, we have the mean, median, mode. And like I said, there are other points in your data set, like the quartile, the decile, the percentile. But all of these are not really as important to us as mean, median, mode. And we also have the measure of dispersion, I guess. Yeah. In fact, I even gave an example of mean, median, mode. Now, mean is just average. Mean is the center. And so let me say I'm interested in the average age of people in this class, or in this call rather. Yeah, I can just sum your age, your age, your age, your age, and divide by the number of people, and I get the average. But there is one property of age, or sorry, of mean rather, that is very important. Mean is very sensitive to outliers, meaning if there's an outlier in your data set, the mean will be heavily affected by it. Now let us use this example right here. I think I have one example right here. All right, so let's say I have a salary range of people. Okay, so 40,000, 45K, 50K, 50K, and then we have 10 million here. Now obviously, if you get the average of this thing, the average here is going to be 2.37 million. So you are telling me that these people have money. So if you look at this average value, you might be thinking, they have money in this place. So whereas it is this person's value, it is this person's earning that skewed. Yes, that's what we use. That skewed the data set. But let's say we don't have outliers here. We have 40K, 50K, 45K, 50K, and 40K. So the average earning of these people right here is 45K. It's the center value, which is still fair. But if you go and throw in an outlier, it will be what? 2.37. It will not be looking like they have money, whereas they don't have money. That is why in real life situation, whenever they are reporting stuffs like income, salary, or anything that has to do with money spent, they use median. They use median because median is not sensitive to outliers. Irrespective of the size of the outlier you use in your data set, median will never be attracted to outliers. So this is one very key thing you to understand. Don't go and be reporting salary with me, no, where there is outlier, because obviously a lot of people earn money in Nigeria. I earn like, let me say, like 50K in a month, and there is Dangote somewhere. Oh, Dangote is too far. My Oga Mr. Adewale is earning like 1 million in a month or 2 million in a month. You understand? His own salary is an outlier to my own, because a lot of us, all right, yeah, probably few of us earn like, let's say, 100K, 150K, 200K, but his own 10 million is an outlier. So if you want to factor in his own salary into the analysis, you will not remove it. It's a value. Like we used to say, it's not all outliers you remove. There are some outliers you have to find way around. So because its value is very important, we still have to find a way to factor it in, and that's where median will come into the picture. So mean gets the center of your data set by making use of the individual values, but the median gets the center by making use of the positional value. So if you notice, median gets the middle value via a position, but mean uses the values in the data set to get the center value. Now, in statistics, you say the mean is a quantitative approach to center. The mean is a quantitative approach to center. The median is a qualitative. Qualitative means it's more of categories. It's more of position. So the median use a so the median is a qualitative approach to data. Now, when you combine the mean, median, mode together, you can be able to tell the skewness of a data set, but that is more or less like it's more like research, which you don't need for now for data analysis. But most times in the future we usually niche down. So maybe in the future some of you might want to niche down to might want to niche down to research. So let's talk about the measure of dispersion. Remember I said there are two types of numerical summarization: measure of tendency and measure of dispersion. So measure of dispersion determines the spread of your data set. It determines how wide you are. How wide is your data set? And under this we have the mean absolute deviation, we have the standard deviation, we have the variance, and we have the range. Now, if you have used Excel before, you notice that Excel has several formulas that can allow you to calculate the range, variance, and SD. Now, each of these have their use case application, but the most popular way of measuring spread is standard deviation. Now, let me give you a typical example of standard deviation. Now, if you have a high standard deviation, if you have a very high standard deviation, it means that your data sets, each of the values in your data set are very far from the mean. So that means if the mean is like 3, the next value can be like 100. The next can be like 200. So that means the values are actually very, very far from the center. But if you have a low or a fair standard deviation, it means that the values are very close to the mean. So for example, now, if you go back to this example, now this data set here is going to be having a very small standard deviation compared to this one. So that's why in Nigeria, wealth is not evenly distributed, because someone is earning like 150K now. If you look at the next person, give or take 10K or 20K per month. If you give like the person is like 10 million. So there is this huge or this wide spread between the center value. Now the government said that the in quotes the average value, the minimum wage in Nigeria now is 70K, right? Is it 70K? Yes. So 70K is the center, is the middle value, is the minimum, is the average in this case. Even though it's minimum, is the average, meaning on average in Nigeria should earn 70K. There are people that they will earn more than this 70K, and whether we like it or not, some people will still earn lesser than this 70K. So the farther we are away from the center value, the more spread out the data set is, and the closer we are to the data set, the less spread out the data set is. So like I said, there are several ways to measure spread, but the standard deviation is the best way to measure spread, and that's it about that. I won't say more about this, but if you want to learn more about this, you can read this book, and you can also watch YouTube videos. I have some videos on my channel. You can check it out after this whole session. Now let's talk about the second part of statistics. All of those things so far I've been saying have been descriptive statistics to describe your data set. The limitation of descriptive is that it does not make conclusion. Now, when somebody plots dashboard make dashboard and say, oh, based on my dashboard though, I've performed EDA. EDA is what? Exploratory data analysis. That is still descriptive statistics, because you are trying to see inside how the variables are interacting with each other. Oh, based on my bar chart, oh, this product is being sold more. Now, according to you, you might be saying we have the highest revenue from this product, but statistician will be like, no, this profit you are seeing right here, is it by chance or not? Is it by luck? So if you want to go further to make an actual conclusion, inferential statistics comes inside. So when somebody makes a dashboard to you and they're trying to make conclusion with just bar charts, pie charts, so because this one has tall bars, it is the most profitable, it might not be it. So descriptive statistics helps to summarize or describe the data set, but it will never make conclusion from the data set. Now, the branch of statistics that is responsible for decision making from data set is known as inferential statistics. So I used to see a lot of people, they make decision from descriptive statistics, and that's fine. It's a mistake, but I just assume that, well, it's where they know how to do, like it's what they know how to do. But in the real term, in the more confined manner, you're supposed to make decision with inferential statistics, not because of the fact that you can see a larger sector here, it is the most profitable. That is wrong from the statistics as a point of things. But then it's like the norm now, so I hope things will change. So the basis of inferential statistics is to use a sample data that has been collected from the population data to make inference regarding the population. Now, this sentence has a lot of meaning to it. It's the basis of the whole thing. Now, when paid HR on Twitter made that made that report, they did not ask all Nigerians how much they earn. According to them, they took a sample of 1,500 people around Lagos State, in fact, around Lekki, to make their research. Do you understand? So that 1,005 right there is a sample data. But we have a population data, and that is the whole of Nigerians staying in Nigeria. But they were able to extract 1,005 to make inference on over 200 million people. Now, it might be like, Abefe, look at it now, 1,5 to 200 million. It is far now. It's actually far. But if they use the right sampling technique to extract that sample, a sample of 1,005 can make a very good, accurate prediction on 200 million people. Do you understand? So this one is another thing entirely, how to sample. So I respect the statistician or the researcher on that thing, because she did, yes, she's a she. It's a she, yeah. She did a very good job in extracting that sample. It's just like our ladies now, all men has come. We have over 4 billion men in the world, and you just dated one and you say all men has come. So you're using one man to judge 4 billion men. Try them more first, then we can see. That is statistically wrong, okay? So sorry for that, but that's just a joke. So to be honest, it is more than this, but that is inferential statistics in its simpler form. How you can use small sample data to inference a large population data. The goal of inferential is that you take a very small sample, but that small sample is very powerful to inference a population data. Now, under inferential statistics, we have stuff like the sampling and sampling techniques, the confidence interval, probability distribution, hypothesis test. Now, all of these are more of statistical techniques. I won't lie to you and tell you will use this in data analytics. You might not. You might not. But situation might warrant itself where you are the data analyst. I'm like, our data guy, come, we get one research for this side. You not be looking. Me, I don't know statistics, so you've messed up, because it might come up. Now, imagine if that lady now that did that research, they asked her, I want to do a research, and she was like, me, I don't know statistics, so she might lose her job, probably. So, in as much as in our Nigerian space, we usually say, don't worry, Daddy, don't stress. Please learn it. And in fact, it's not bad to know all of those things. It's actually not bad. It adds to your skills. No, so under inferential statistics, so this is everything. Oh, and that reminds me. So how will I forget probability? So a probability is also a very important aspect of statistics, and of statistics. So we have so Your probability is like a bridge that connects both types of statistics. In simpler terms, if you need to make transition from descriptive statistics to inferential statistics, then probability is going to help you do that. So people that do research more will understand this statement, because if you want to now move from, after summarizing your data set with with DS, you now want to make inference. So that technique that will make you move from descriptive to inferential is probability. Now, to be honest with you, it is people in machine learning that would need all of these ones, because as a data analyst, most times you might not need to come across all of those ones. You, in fact, sorry for speaking Yoruba, you are not doing tests now, so you might not need this. But people in machine learning, this guy here, these two guys here, they don't joke with it. Because we have a theorem, a model in machine learning called naive Bayes model, which is based on this guy. So they need this one, but that's by the side. So if you are here and you think you might want to enter machine learning, go and start dusting your statistics and mathematics very well. You will need it. So now that I've tried to talk about the types of statistics and what they do, it's time to talk about the backbone of statistics, the backbone of data analytics, and that is just data. Now, basically, data is what statistics is all about. So that means that if we don't have data, we can't have statistics, neither nor we can have data analytics. So it only makes sense for us to talk extensively about data. Now, there are several scholarly articles about how to define data. Data is different from information. Data is this, data is that. Is it data or data? Anyone they want to say, I don't care. But we have something called data, and let's just define it the best way we can. So, in simple terms, data is simply any useful piece of information that has been collected over time. See, so time is a factor whenever you are collecting data. See, this is something you have to pay attention to. Time is a factor whenever you are collecting data. So data is simply any useful piece of information that has been collected regarding a group of people or a group of things. Now, I cannot take it further and say either from a population or from a sample. Now, this place is not really needed, but as a statistics guy where I added it. You understand? Someone I know verse, I beg. So, in simple terms, we have, how many of us are here? SF? So let me, okay, I think we're almost 200 here. If I gather 200 people right here, okay, and I ask you guys several questions. What is your name? What's your age? What's your gender? Your blood group? Your this, your that. I am collecting data. I am collecting information regarding you. Now, if I collect this information, I can actually process them, and extract useful insights from them. Okay, but that's not about that. Data is just useful information that has been collected. So there are contexts to data. If I'm talking about health, obviously you see things like genotype, blood group, your height, your weight. If I'm taking data regarding your phone usage, I'll be having things like your type of phone, your battery level, your stuff. And if I'm working on finance, your revenue, your profit, where you work, how much you make in a month. So for you to talk about data, you always need context too. So let's talk about the types of data. Now, this is a very controversial, it's not controversial, but it has several aspects to it. So in statistics, we have two types of data: qualitative and quantitative. Now, in SQL, your data can either be structured or unstructured. So it depends on the standpoint you are talking from. We have several types of data. In terms of how you gather the data, we can have longitudinal, we can have a time series data, we can have a panel data, we can have a cross-section data. So depends. There are several contexts on the type of data set that you have. So always try to understand the nuances or the context you are working with. But from the concept of statistics, there are basically two types of data: the categorical, aka the qualitative data, and the numerical, aka the quantitative data. Some people usually say it is a variable too, so that's why I put it in brackets here. So types of data, types of variable, they are the same thing in statistics. Okay, so as the name implies, a data set is said to be qualitative or categorical in nature if we cannot, emphasis on the word we cannot, very important, if we cannot attach a numerical value to it. And even if there's a number to it, even if there's a number attached to it, that number is only a label. See, one of the things that can make analysis hard for you is not understanding the type of data that you have. Do you understand? You might be thinking because a data has number, it is quantitative. No. Now, examples of qualitative data that are obvious includes gender, your country, your state of origin, your age group, your blood group. One of the properties or some of the properties that defines qualitative data is that they cannot be, you can't perform arithmetics on them. Do you understand? You can only count them or you can only group them. Oh, in this class, on this call, we have 150 males and we have 200 females. Now, gender in this case of ours is a categorical variable. We can't add male plus female. It doesn't make sense. And we can group. If you're a boy, stay here. If you're a girl, stay here. So one of the distinct property that defines a qualitative data or variable is that it can only be counted or be grouped. You can't perform arithmetic operations on them. By arithmetic operations, I mean you cannot add, you cannot subtract, you cannot divide, you can multiply. So numeric value is not the only thing we use to say that okay, it's quantitative or not. Some things can take numbers. Some variables or some data can take number and they are still not numerical. For example, postal code, address, phone number, customer ID. All of these things are numbers, but they are not quantitative. They are still categorical, because if my house address is, or my house number is 53, or let's say 50, and your house number is 20, we cannot say 50 plus 20 is 70. It does not make sense. Or you have a postal code or a customer ID and it has a number and letter, you cannot add it. The addition does not make sense. So I hope that makes sense to you guys. So it's not all numbers that is quantitative. Some numbers might be quantitative. Some data might be quantitative, but at the same time, some data might be numerical, but they are not quantitative. So please, for a qualitative data, you can only count it or group it. You cannot perform numerical arithmetic on them. Very important. Please pay attention to that, because if one of the things you have to pay attention to before you analyze data after preparing it is to understand each of the columns that make up your data set. Very important. Oh, I can see sales here. Oh, I can see a quantity here. Oh, I can see types of good here. What is that? It's quantity. It's quantitative. It's categorical. If you can detect the types of data set, it will aid your analysis. It will, because some things can only work with categorical data. For example, your bar chart never works with quantitative data. Bar chart is usually for count of categorical variables, but your histogram will always work on quantitative variables. These are things that you should know, but we'll get there. So under quantitative data, unlike your qualitative that cannot be quantified, unlike your qualitative that cannot be quantified, the quantitative data can have a numerical value attached to it. It can take a number. Do you understand? So once you see that something have a number, and when that number is given to you, it can be added or subtracted, meaning that when it comes to quantitative data, arithmetic can be performed. Take for example, you can get the sum, the average, the squared of age in a variable in your data set. Yes, if I have my age, I'm 50 years old, and this guy is 20 years old. 50 plus 20 is 70. That makes sense. It means that the sum of our ages is what? Is 70. It makes sense. The difference of our ages is 30. It makes sense. And we can divide it and multiply it. So whenever you perform arithmetic operations on something and it makes sense and it is a number, then that thing is a quantitative data. Sales, profits, quantity, all of these things are quantitative in nature. Now, I'm using sales and all of these business thing because a lot of the times the type of data sets that you find yourself in this space is usually business and finance. I'm sure a lot of us have come across the superstar data set. There's no way you cannot tell me you've not seen it. A lot of people have seen that data set before. So you understand. So that's just it. So please pay attention to this. Very important. Very, very key. Okay, I have to speed up. All right. So now I can also go as far as saying we have two types of quantitative data. Now we have two types of quantitative data. We have what we call the discrete data, and we have the continuous data. Now, so this one is just like an advanced thing. It's not like it's really necessary, but it makes sense to know that under a quantitative data, okay, it can also split into two. We have the discrete and we have the word continuous. Now, discrete means, discrete means countable, finite. When something is discrete, it means that thing is countable. It means that thing is finite. So that means that a data set is said to be discrete if you can count it, if it is finite. Example: number of books, number of cars, number of children. How many are you guys in your family? You can say 10, you can say 5, you can say 50, but you cannot say 2.5. Who is the half in your family? Nobody. How many cars do you have? I have 3 cars. I have 4 cars. I have 0 cars. Sapa. But I cannot have 1.5 cars. It's not possible. So quantitative variables that cannot take that cannot take decimal values, meaning they have to take whole numbers and they are countable. We call them discrete. Example: quantity sold. How many units of goods are you buying? Oh, I'm buying 10 bags of this, 5 bags of that, and all of those things. So whenever something is countable and it can only take decimal value, then it's a discrete variable. On the flip side, we have the continuous data. Now, so a variable is said to be continuous if it is infinite. Now, by infinite, it means that the value can take a range of value. So the value is not standing. It can take values between one range or the other. Now, I will use a speedometer as a typical example. A speedometer, if you look at a car and you look at the speedometer, it starts from 0 and it ends at, let's say, 250. The speed of your car can be between 0 and 250. The lowest is 0, the highest is 250, and it can take decimal value. Do you understand? So a car can be running at 256.7 kilometer per hour. That is a continuous data set. So one of the things about continuous is that you cannot count it. You don't count continuous, you measure them. So any quantitative variable that you measure, not count, that you measure and it takes decimal values, is continuous. Example is pressure, weight, amount of money, profit, sales, revenue, and so much more. Those things that they can take value, they are always in between. Okay, they are continuous. See, you can learn more about these things, but I don't want to waste much time on them. Then we now move to the beautiful part of statistics and data visualization. A lot of people like this aspect. It's very beautiful. I used to tell people, if you come to Twitter Nigeria and that is your first time in data, you will think data viz is the most important aspect of data, because everybody is always making dashboard one way or the other. Everybody is eager to make dashboard, and which is fine. It's okay. In fact, we hosted a space one day, not one day, yesterday, and somebody was like, he got a job as a data analyst and he's surprised that he has not even plotted the dashboard in a very long time. Don't get me wrong, dashboard is very, very useful, but it is always the last aspect of analysis, not the first. You understand? Because for you to plot dashboard or make dashboard, you must have analyzed your data set. That's why I've seen people that are making dashboard, but they did not clean their data. So what are you making dashboard for? So please, if you are here and you are trying to start your journey, please learn this thing the proper way. The first step is to learn how to collect data. then how to prepare data, how to analyze data, and how to visualize data. Visualization is the last part, and it depends on all the first three steps I mentioned. If your analysis is wrong, if your data is wrong, your vis is trash. But then I won't lie to you, when you like visualize, it is very beautiful. It's very attracting. Like I said, we humans are attracted to pictures. So it only makes sense that once you start data dashboard straight and you start doing it, it's fine. But please have it at the back of your mind that that is not the most important. In fact, that is the last thing that you need. But it is also important in its own way. Now, when information about variables that makes up a data set is known, it is easier to analyze. So when you understand the variables in your data set, it will be very easy for you to visualize that same data set. That is one thing that people miss out. So somebody is using line charts here. There is a reason why he's using line charts. He's using a bar chart here. There is a reason why. Histogram here, reason why. So we don't just drop bar charts, pie charts, histogram everywhere because we want to. There is a reason. Okay, now this aspect of the course will focus on how we can use all that we have learned about variables to visualize data sets. Yeah. So data visualization is the uses of charts and tables to summarize and tell a story about a data set. Now, people that will teach you Excel Vis and Tableau and Power BI will talk more on this part so you understand it better from them. So the type, now very important, now the type of data visualization chart that is used is dependent on the type of variables or the type of data and the number of variables that you have. What do I mean? Now, let's say you want to visualize the count of goods. Probably you are selling consumer good, we are selling producer goods, or no, wait. We are selling, or I have a store and we are selling food items, we are selling gadgets, we are selling toiletries. And I want to plot, or I want to visualize the count of goods category. In that way, I only have one category, is group category. I will use a bar chart or a pie chart. Now, the pie chart and the bar chart are very similar. Just that the bar chart can handle more categories, while the pie chart, due to the fact that it can get clumsy easily, we try to use it not less than 5 categories. But let's talk about those things in bit, because I'm sure that once you start doing Excel and Power BI, it will be talked about. So a bar chart is a visual tool that is used to visualize the frequency of a categorical variable. Now, guys, listen. A bar chart is used to visualize the frequency of a categorical variable, like the example I mentioned earlier. A bar chart can also be used to visualize how a numerical variable varies over a category. What do I mean? Now, let us take revenue as an example. We all know that revenue generated is a numerical variable. But if they now say, okay, in Nigeria, revenue generated by states, sum of revenue by state, average revenue by state. So it means that what we've partitioned a numerical variable based on category. So you can use your bar chart to represent the frequency of a categorical variable. At the same time, you can use your bar chart to visualize a numerical variables that has been categorized. Pay attention to that. Please, very important. Now, there are 3 types of bar charts. We have the single bar chart, which is basically used to visualize a single categorical variable. We have the multiple or the grouped bar chart, and we have the components bar chart. Now, these two, they are the same thing. So you just choose them based on your choice. Now, you can plot your bar chart either vertically or horizontally. Now, a single bar chart is used on a single numerical variable like this, or a single category, while your multiple bar chart is used for 2 categorical variables. So I actually have a picture here of a bar chart. You must have seen it. So this is a single bar chart. This right here is a stacked or components bar chart, and this right here is a multiple bar chart. So if you notice, these ones here, the categories are placed next to each other, and this one here, they are stacked on each other. So these 2 guys here, they are the same thing. So you only use them based on choice. Now you can plot them either vertical or horizontal, it doesn't mean anything. I can do like this. It's still the same thing. I can bring this one like this. It's still okay. All of these ones, they are just styles. It doesn't mean anything. So you can plot your bar chart either horizontally or vertically. So that's fantastic. So what's the next visual tools? Now, the brother of a bar chart is your pie chart. Now, a pie chart is similar to a single bar chart in the sense that it is also used to visualize the frequency of a categorical variable and also how a numerical variable is distributed over a category. Unlike a bar chart that uses bars, your pie chart uses the sector of a circle. I'm assuming we all know what sector is. Now, so this is what a pie chart looks like. Now, a pie chart also has a variation known as a donut chart. So this right here is a donut chart. Your pie chart uses sector. Your donut chart uses segment. Now, so this is small mathematics here, but I don't need it. So the larger the sector, the more the count or the frequency. And the larger the area of the segment, same thing happens. So let's go to the next one. We have the histogram. Now, histogram may look very similar to a bar chart, but there is a huge difference between them. Now, I'll be fair with you. We don't use you will hardly see histogram in data analysis in people's dashboard, and that's because the functions of histogram is way above just categories and just try to describe. Histogram is one of the pioneers of statistics. Histogram can go a very long way. Histogram can used to detect outliers. It can work on skewness and kurtosis. It can give you a lot of things. So histogram is complex, and whenever you are visualizing, you try to tell the story the simplest way we can. So that's why the likes of bar chart and pie chart, you usually see them because they tell the story straightforward. If I show you an histogram right now, you'll be looking like, yeah, what's this? What's this saying? And stakeholders not to submit technical stuff like that. So you have to use something as simple as possible. So that's why we can never see histogram in people's dashboard. It's complex. All of these things here have a very huge meaning. Skewness, kurtosis, distribution, all of those things. So you will not see histogram. But if you are doing machine learning, yes, or you are doing research, you must definitely understand how to read these two guys. They are very important. So basically, this is just it. I won't rush through it. It's not really that important, but it's something you can just probably watch or learn more about. So let's move to the next one, line chart. Now, your line chart is also one data visual or one visual that is heavily used in people's dashboard. Now, the line chart is basically used to visualize how a variable changes over time. Now, whenever you want to show how a variable is changing over time, you use a line chart. Now, that reminds me, a bar chart can also serve this purpose. Yes, because time, month, year, day is a category. So you can use your bar charts to visualize the change of profit over the days. But most times we prefer to use line chart because line chart is more visible than bar charts. You understand? Now the line chart, a single line chart, is quite similar to a single bar chart as the time, either year, can be seen as a category. I've said this before. Now, a line chart is very common in financial and business analysis. Yes, you can see it. So we have three types of line chart: the single line chart, the multiple line chart, the compound line chart. When you combine a single line chart with a single bar chart, we have what we call a combo chart. So that's something else entirely. It's just when you combine your bar chart and your line chart. So let's go about it. So this is a single line chart here. In this case, I'm visualizing sales over time. This is a multiple line chart. I'm visualizing the temperature of four cities: Tokyo, New York, Berlin, and London over the year. Now, the compound line chart is almost similar to a multiple line chart, just that in this case, you are looking to the area under the curve. So the area is important. So it's still the same thing: frequency, count, time. We have cars, bus, bikes, but this time we now have like the area. So these two are sort of similar. So you just like need to pick the one that suits you. And the last but not the least, now, so this one too, you hardly see this one in people's dashboard. But if you are doing more of technical reports, you will see scatter plot and histogram there. So this is a visual aid that is used to visualize the strength and direction of association between two numerical variables. So far, all we have been doing have just been just one variable, one variable, one variable. But when you want to visualize two variables or two data points in quotes at the same time, scatter plot comes into the picture. So are you working on a business data and you want to see the relationship between price and quantity? You are going to be making use of a scatter plot. Now, the scatter plot is the basis for regression and correlation analysis. Now, people in research and machine learning will understand this guy better more because we use it a lot. So this is what is a scatter plot looks like. So from your scatter plot, you can get stuff like zero negative correlation, positive correlation, zero correlation. All of those things will be told by this, and they have their interpretation. So that's the end of the class. I met it on 4 on dots, so that's so fantastic of me. So we have some quiz and evaluation, but before then, I think I should just stop it here so that the moderator can actually take things from there. Then we can know the next thing to do. Yeah, thank you very much for having me. I'm open to questions and quiz and all of those things. Yeah, thank you.
Thank you very much, sir. Thank you very much, sir. Hello, sir.
Yeah, I'm here. I'm here. Yeah, I'm here. I'm
Yes,
here.
sir.
Yeah,
Thank you
thank you.
for the amazing session, sir. I really learned a lot. Maybe me too, I will be doing some regression impact analysis at work.
No, yeah, sure. You might actually. So yeah.
Okay, no problem, sir. So the next step for us is to answer some question based on the number of hands raised by the respondents. So we will be unmuting some people's mic for them to have the floor to ask you questions, sir. So we can see a lot of people are raising their hand. So I'm going to grant some people access.
Yeah,
Okay.
please, if you have questions, please can ask. Yeah. And I could see some
Okay.
questions on the group. Yeah, I'm more on research. I do research, I do machine learning, I do statistical analysis. I'm statistics guy on Twitter. So anything statistics and data and machine learning and research, it is my thing. So thanks for the nice words in the comment section, by the way.
So for I've unmute some people, Temidayo Popola. So you have the floor now. You can unmute your mic and ask a question.
Yeah, thank you very much, speaker. I really appreciate. Thank you for the great insight. Yeah, it's a great insight to be honest. But most of the charts talking about going deep into statistics. I think from my own aspect, I don't know. I don't. Let me just be honest because I'm a data scientist. From my own aspect, I believe is more of if you're going into data science or research, not to the extent of data analysis, because in data career, I believe data analysis is just the foundation. Let me say, is the bedrock of the career of using data. So because if we look at what's it called, Power BI and Excel, they are more like a visualization tools to do less visuals, but not going into forecasting or predicting the business or the nature of the data. So I'm just asking. So the question I'm asking is, do we have a space where we can visualize these scattered plots, uh, correlation, do more of regression, do more of in-depth analysis in this Power BI and Excel?
All right, so basically, thank you very much for that question. You see, there are tools, and tools have specialty. Do you understand? So, there is a capability of what your tools can do. The likes of Excel, Power BI, Tableau, they are more of a data analysis, business intelligence analysis tool. In fact, Your Power BI and Tableau, in as much as they are seen as visualization tools, they are more of BI tools. So most times, all of these technical visuals, you will not see them there. But if you go to R, SPSS, Minitab, Starter, GraphPad Prism, all of these things are statistical tools. So all of the complex and more vigorous charts are there for researchers and people that wants to do machine learning. So what I'm trying to say is that you just use your tools based on what you want to do. My oga gave me the direction of Abefe, it is statistics for data analytics. So if I were to teach statistics for machine learning, obviously I will go in depth into all of this because you are going to be using all of this chart for your feature importance and all of these explainability of your machine learning models. So yeah, for the context of data analysis, bar charts, pie charts, line charts, they are enough. They pass those three. Any dashboard you see in this life, they pass those three. You can never see a box plot in somebody's dashboard, and this box plot is useful in machine learning, is useful in research. Histogram is useful in machine learning and in research, but you won't see them in people's dashboard because see, when you are doing your visualization, the goal is you want to simplify things. So you don't want to be using complex stuff that will make stakeholders say that, oh my God, so we have to stick to the least confusing visuals out there. So for the more complex stuff, they will leave it to the people that wants to use it in research and machine learning. Thank you very much, sir.
Yeah. So the reason why I'm asking is because in Power BI I can see that you can integrate a PY, that is the Python
Yeah.
library, and the what's it called, the
R,
R
R.
language into Power
Yeah.
BI. R into Power BI. So that's why I'm asking that. Can we use it? Can we integrate such when we are
Yeah,
doing
yeah,
more of rigorous analysis, like forecasting, going in depth to do
yeah.
like
It's
so
just
that's
of
what I'm
it's
saying.
more of use case. It's more of use case. I won't lie to you. It is what you need, you will do. If you don't need forecasting, you will not use the forecasting visuals. If you need it, you will do it. So like I said, most business analysis and business intelligence analysis, they don't really like go far into all of those things we are saying. So if you feel like you need to do mad visuals and Tableau does not have it, Tableau went as far as integrating itself with R and Python so that those higher visuals that are not there in their own normal listing, you can use it there. So that is if you don't want to use Python or R straight up. So it's just like use what you want to use. So I get your point, sir, and it's very fine. Thank you very much, sir. Next question,
Thank
please.
you.
Okay, sir. Ale Bioshu Onoluapo. You can unmute your mic.
All right, thank you very much. Hi, Mr. Yusuf. Good afternoon.
Yeah, good afternoon.
The question I want to ask is concerning pie chart. Is it possible for the total segment in a pie chart to be more than 100%? Or is there an
Line.
exception?
Yes, I remember this thing. Okay, this thing happened on Twitter. Punch newspaper posted so there was this, I've forgotten what happened that time. So a Punch newspaper posted something on Twitter and the pie chart was more than 100%. So I commented and I was like, OTG 100% low, and they deleted that post. So it is never possible. It is mathematics. You can never create nor destroy. E no go pass 100%. There is no use case. There is no 2 plus 2 can never be 70. Don't let anybody say a wuru wuru and add it. Lie. Your pie chart must never pass 100%. It is a sector. The total area under a circle, under a circle is 100%. So a pie chart is how you can cut and cut and cut. You have $100 in your account or 100K in your account. If you share it among every other person, you cannot have a total of 110. Where is that extra 10 coming from? Did you steal it? So it is law of conservation. Anything can never be created nor destroyed. So you cannot go and bring something that is not there. So that 100% is a constant value. It cannot change. So by the way, please, I'll be linking my YouTube channel right here in the chat. You can check it out. I've sent the YouTube channel that you guys can check it out. I teach a lot of statistics right there too. And you can also message me on Twitter. If you DM me and I don't respond, please just tweet at me. Next question, please. Thank you very much, sir.
Okay. Abimbola, you have the floor now. Abimbola.
Hey, Abimbola, how are you doing?
You can unmute your mic. While we are waiting for Abimbola.
Okay. Yeah, Abimbola is talking now.
All right, so I wanted to ask about something. I got lost during the meeting. It was talking about outliers. You said we use outliers when you were talking about salary of the stuff that we use outliers of other people's to like compare with your own. Is it really necessary to use those outliers? And is there a particular meaning for the outliers?
Okay, so something about outliers is that, see, in data, in fact, somebody still asked me this question today. He's one of my students in the US, and he asked that, how can I approach this outlier? See, outlier is a very sensitive topic in the data space, because if you miss it, you've missed it. Now, so for example, so let's say we have teenagers in this class, and we are asking for age. So you can be seeing 19, 18, 17. Imagine I'm now seeing 100. Obviously, that 100 is an outlier. In simple terms, an outlier is a single value that is either extremely large or extremely small regarding to other variables in your data set. So in the context of this example, 100 is an outlier because I am collecting data regarding teenagers. Anybody that is 100 years is not a teenager. So meaning that maybe when they were filling in the data set, somebody wanted to write 10 and mistakenly wrote 100. In that case, that is a bad outlier. You will remove it. But it is not all outliers that you remove. And I used salary as an example. I'm earning 50K, you're earning 100K, and somebody is earning 1.5 million. That 1.5 is an outlier, but you will not remove it because it is a value. So that's why in statistics, there is a special aspect that talks about how we can approach outliers. There are several approaches to outliers. A lot of them. So some outliers, you have to use them that way. Some you can remove, some you don't remove, some you have to remove some parts of them. So this is quite a technical aspect of data, but luckily for people in business intelligence, business, and you might not meet outlier that will stress you. You might not, but just pray that you don't meet one that will stress you so much, because if you meet some actual outliers that can have effects, for instance, outliers can have effects on your data set. So there are several ways to handle it, even in machine learning too. But it's above the scope of our topic. So when we get there, inshallah, we'll do it. Thank you very much. Next patient. Next person.
Thank you, sir.
You're welcome.
Okay, sir.
Yeah. Hi, Mr. Wahid. Okay, is it Wahid? Oh, sorry. It's to Watokbe, Abi?
Mr. Abdul Wahid, yes.
Okay, it's Mr. Abdul Wahid.
You can your mic.
Okay, good afternoon, Mr. Befe.
Thank you very much, sir.
Okay, thank you very much.
Welcome.
I think I was talking about the outliers before you mentioned patients inside statistical class. So that would have been an outlier. But I just want to corroborate what you just said, because I've always, should I say, have a different view on all these our tools. When somebody asked, when you mentioned bringing in R into a case like this, number one, for people like us that are still learning data analysis gradually, what your clients require from you will even determine the kind of statistical tool you use. You may use Excel, Power BI, and you're fine. But just like you said, you want to go to some more technical things and you need to use R. So thank you for shedding more light in that, because I've always wondered, where does R even come in? I've told somebody somewhere that, oh, the same way you use SPSS, you can use R for this. But the person was just looking at me, if you use R, you will explain tire. But thank you for shedding more light on that. Thank you.
Yeah. Like I used to say, every tool have their own use case and strong points. It's just like when you enter the kitchen now. We have knife, we have spoon, we have fry pan. So all of the tools have their use case. Now, Excel number one. See, the reason why they tell you learn Excel is because Excel is like a general tool. Excel does not do one thing in particular, but Excel can do a lot of things. Excel is everywhere. It can visualize small, it can analyze small, it can do statistics small, it can do data management small. But when it comes to proper visualization and business intelligence, it is Tableau and Power BI, at least those two. There are more. We have Looker, we have Google Studio, but those two are the most popular. When it comes to research and statistical analysis, read my lips. When it comes, no, you cannot see my lips, but read my words. Listen, but when it comes to research and statistical analysis, it is R and SPSS, and maybe Stata. Stata is more of econometrics modeling, but Stata can also function for statistical analysis. But when it comes to machine learning properly, you can use R, you can also use Python. In fact, Python is the god when it comes to machine learning, because a lot of libraries, skitlearn, and all of those guys, they've been built to build machine learning models on using Python. So depends on the scenario. So most times, all of this learn Excel, learn Python, you feel go get job, maybe say na only Excel you go use safe. That one safe dey. So all of these, go and learn this one. We only learn multiple tools because we want to open our chance of getting a job. We want to increase our chance of getting a job. Do you understand? If you want to query a database, use SQL, obviously. There are other tools too that can do it, but SQL is the most popular. So tools they get name pass themselves, but all of them have use case. Python is not scary, oh. Python is not scary, oh. It's just basics. You can understand it. Thank you very much. Juliet is not scary. All right, next person, please.
So thank you, sir, for that, sir. So,
Yeah, you're welcome.
where you can unmute your mic.
Hello. Good afternoon,
Hey,
Mr.
yeah, good afternoon. Yeah.
Thank you for today's class. My question, I have a question as regards the use of pie charts. Yeah. So my question is, how many categories do you recommend is shown with a pie chart? Because I've discussed with some people before. Some would say, oh, just you when you have only use the pie chart when you have 3 categories. Some will say, don't let it, just use it when you have 4. And during the course of the class, you mentioned that if we have 5 categories, we can use a pie chart. So what would you recommend is the right number? Because if we use too many categories, it might overpopulate the pie chart, like you said, and it will not make sense.
All right, so basically, okay, so give me a second. Somebody said, Abefe, can you share with us about pandas and Python? Please send me a DM on Twitter. I would help you on that. Thank you very much. So, see, the essence of data visualization is to make sure that if somebody opens your data or your visual or your dashboard, they can see it ASAP. Like they will understand it, and there will not be need for them to start stressing themselves, trying to, understand. So we know that a pie chart uses sectors, and as sectors get much in the circle, the readability becomes very low. So there is a general rule of thumb. I don't know who agreed, but they said at most 5 categories. So can you do more than 5? Maybe in some categories. But when you notice that you are splitting your pie chart into sectors, and the sectors are now trying to have is not trying to affect the readability of your visuals. Please use a bar chart or reduce the sector. So it's all about choice. If you notice that you can use test sectors in your pie chart and it will not affect your readability, use it. But once you notice that the number of sectors you are using is beginning to affect how readable your codes, your visuals are, please change it. Because the essence of data visualization is to make sure that your story is well told. As simple as that. Is that making sense to you, sir?
Yes, sir. Yes, sir.
Yeah, thank you very much.
All right. Thank you, sir.
So, sir,
yeah,
thank you for the wonderful session. Tiwatokwe again. Okay, we don't have any more questions, sir. Thank you for the amazing session. We are glad to have you here. I really learned a lot from you. And okay, somebody has another question, Tijani.
Okay, that's fantastic. That's okay.
Okay. Tijani has lower his hand though. So thank you very much for the wonderful session, sir. We really appreciate. Tijani, you have the floor. You can mute your mic. Hello, Tijani, you can unmute your mic. I think he's trying to say something. We can't hear you.
Hello, can you hear me now?
Okay, yeah, we can hear you now, sir.
Okay, thank you, Mr. Adebe, for the wonderful section. So
the pleasure is mine, sir.
My question is actually about I want to ask about missing data. So what can you tell us about it?
Missing data, that's another thing entirely. So the way you handle missing data is also it's contextual in the sense that once you see missing data, if the data set is given to you by somebody, by your boss, so let's assume you're working in a firm now. Once you see missing data, the best to do is to go back to who gave you data to ask for more context. Because there are some missing stuff that you can use techniques to fill. Yes. Like you can use me to fill it, medium. But before you start filling missing data, always go back to the source of data to get context. There might be a reason why there's a missing data there. So when it comes to missing data, I cannot tell you remove it, fill it, don't fill it. I can't tell you that. You have to still go back to whoever gave you the data set, get more context, get more information. Then that way you can maybe now say, okay, based on this, so I want to use this method to approach this missing data. I want to use that method to approach these null values. Is that making sense to you?
Yes.
So I won't just tell you and say, yeah, I've gone. So like whenever you see missing data, do this. Whenever you see missing data, do that. No. Even my old guy here will tell you that whenever you see missing data, always go back to who gave you the data set. But there are several methods, there are several techniques that we can use to handle missing data, and they have their use case scenario. One of them is using mean, and you can use your mean to fill in missing data if you are working with numerical data. But that is just one use case. There are other use cases. So thank you very much for that.
Okay, thank you, sir.
Thank you very much, sir. Please, we have seen some questions relating to this missing data in the chat before, sir, and I would like to ask question based on the question I have seen on the chat. Sir, in case we have a situation of missing data, can we just filter it out because maybe we are dealing with BI financial data, send it to the boss, maybe the receipt ID, so that they can tell us the amount for that day? Because some people are thinking that if you put in the mean value in there, it might affect the total amount and it can cause wahala.
Yes, no. It will cause wahala if you go, and that I'm saying you can't just see when it comes to, especially if you are working with very delicate field like finance or medicine, where any little mistake is costly. So whenever you find missing data, you might have your idea in head. Oh, let me use this technique to fill it in. Let me use that technique. But always take it out and go and filter, like you said. So give it to your boss. Now, wait till your boss talk, you go report back to. You can only now use any method you are using. If you are using a dummy data, like you're just using just this random data you had, that one you can do anything you like. But if you are working with an actual, see, there is a reality check between working with a dummy data and an actual real life data. I pray everybody have access to work with an actual data that is real life, like it's a job. So there is different, because that way you will not just be doing anything anyhow. You keep going back to your boss and be saying, sir, based on this, so see what I see you. See what I see you. So whenever you find missing data in a real life situation, please always go back to whoever gave you that data, especially in business, finance, health, or medicine. It will go a long way. So that way they cannot tell you, oh, this missing data. Now, because say you get one thing, let's ask the people, yeah, they turn it back to us. So that's the best way. That's the best way to handle a missing data. To me.
Nice.
Thank you.
Thank you, sir. Bella, you don't have any question. We allow one more question for him, and we